Special parallelograms. So we've learned properties of parallelograms themselves. Today we're going to learn additional things about trapezoids, kites, and also rhombuses, rectangles, and see some of their properties that are special to them. Let's skip the warm-up because I think the notes are a little long. But it just had said to sketch and label and mark a rhombus and a rectangle. All right, so again, we have some theorems. The numbers are irrelevant. Okay. The content is what is important, and all of these will need memorized. I will be giving you tomorrow, not today, because I don't think we'll have time, a concept map that will have all of the shapes and all the properties, so you kind of have like one study sheet instead of having to go back to each note sheet. That'll give you every property that you'll need to have memorized. Here are some additional ones. Each diagonal of a rhombus bisects two angles of the rhombus. I think you're just filling in bisects on your sheet. Two angles of the rhombus. So notice we have a rhombus here. The diagonal will bisect each of the angles. To bisect an angle, it means it cuts it into two congruent angles. So angle 1 would be congruent to angle 2. Now, the question is, would we put different markings on 3 and 4 or not? Well, take a look at the triangle that has been formed. What type of triangle is that? Triangle ABC? Maddie? Good. This is an isosceles triangle. We know an isosceles triangle is two congruent sides, and then we learned the isosceles triangle theorem that says if it has two congruent sides, then it has two congruent base angles. So 1 would have to be congruent to 3, and same thing over here, 2 would have to be congruent to 4. So they should all get the same marking. Okay. So here it says that segment AC bisects angle BAD. So angle 1 is congruent to angle 2. Segment AC also bisects the other big angle, which would be angle BCD. So therefore, angle 3 is congruent to angle 4. Now, what you have to also remember is that a rhombus is also technically a parallelogram, right? Rhombus is a parallelogram. So it would still have all the properties of a parallelogram. The opposite sides should be congruent. The opposite angles should be congruent. The diagonals should bisect each other. All that stuff that we learned about parallelograms still applies to the rhombus. We're just adding an additional piece to the rhombus. Okay. Next one, the diagonals of a rhombus. We know if it's a parallelogram, they have to bisect each other, but this theorem tells us that the diagonals of a rhombus are perpendicular. You have to memorize all of them, but this one in particular, if you don't memorize, there are a couple questions on your test that you might not know how to solve. Okay. So if you know it's a rhombus, then you can insert 4 right angles in the middle. Because one right angle really means that there are 4. And that would be that AC is perpendicular to BD. Why is that going to be important? Well, if I only give you one of the angles and ask you to find the other ones, you'll need to know the fact that this is 90 to be able to do triangle sum inside of some of the shapes. Okay, the next one is our rectangle. And so we have, if we have a rectangle, which would be that we have a parallelogram that has 4 right angles. And we also should know a rectangle also has opposite sides being congruent. And that's because it's a parallelogram. And a parallelogram has those properties, right? So then the diagonals of a rectangle are going to be congruent. Again, a rectangle is a parallelogram too. So the parallelogram says that the diagonals bisect each other, right? So normally we would put 1, 1, 2, and 2. But because the diagonals are congruent, like if this one is 10 units long, this one is 10 units long, if you were to bisect them, cut them in half, all of them should get the same marking, one marking. So they bisect each other and they are congruent, therefore all four little pieces should be the same. This can be proven using Pythagorean theorem. So like if you were to know that this side was 3 units long and this side was 4 units long, you could do the Pythagorean theorem or use triples to find out that AC would be 5. And then obviously if this is 3, this is 3. And then you could do 3, 4, and find out that BD is 5. So the reason the diagonals are congruent is because they're both hypotenuses of right triangles that have the same legs. That makes sense. Why the diagonals would always be the same length. So this one probably says AC, segment AC is congruent to segment BD. What type of triangles are then formed within our rectangle? What type of triangles do we see in there? What type of triangle is this one? I know we see right triangles, but what type is this little one? Marquise? Isosceles. So you are going to have some isosceles triangles in there. So if you were to know, for example, that the top angle, this angle was, let's say 80, you can always find the other two. Remember, if you know an isosceles triangle has two congruent base angles, 180, triangle sum, minus 80 is 100, and then you can just divide by 2 to get 50 and 50. So you're still going to use a lot of your prior knowledge from chapters 3, 4, and 5 to solve some of these problems. All right. Again, you want to pay attention to what they name the shape to know what you're doing. So find the measure of each angle in the rhombus. Okay. So a rhombus is a parallelogram with 4 congruent sides. Again, as you read, you have to remember all of the facts about a rhombus. Otherwise, you're going to have trouble solving the problems. First thing I would do is mark 4 congruent sides. And then you actually could do this without the theorem we learned, because you should now notice that this is an isosceles triangle. So you could easily figure out what 1 and 3 are. But if you use the theorem that we just talked about, which says that the diagonals bisects 2 angles of the rhombus, if you use that, you can go ahead and mark that angle 1, 2, 3, and 4 are all going to be congruent to each other. But if you did forget that fact, you would be able to figure it out if you used isosceles triangles. So we can use triangle sum. Each triangle has 180 degrees in it. We get that the 2 angles, angle 1 and angle 3, have to add to be 60. So we just have to divide that by 2 to get that each one would be 30. And that would be all of them. Remember, this is still a parallelogram, so the opposite angles have to be congruent, so that would have to be 120. And then, of course, our angles are bisected. Does it say Y on your paper next to the numbers or no? Okay. Next one says, find the lengths of the diagonals of a rectangle. We're given that this is a rectangle. And they tell us that FD is 3y plus 4 and GE is 6y minus 5. Well, the diagonals of a rectangle are congruent based on the theorem we learned. So if they're congruent, then they have to be equal in length. So we would just set these equal. The diagonals of a rectangle are congruent. So FD is congruent to GE. If they're congruent, then they're equal, and we can solve them out. Go ahead and solve that out for y, and find the length of each diagonal by plugging them back in. You can tell me what they got for y. Someone I haven't heard from today. No? Good. Y is 3. And then who can tell me what they got for FD and GE? They should be the same number. Lexi? 13. 13. Very good. They didn't tell us what units, so you can either write units or you could just leave it blank. I won't take off points if they don't give it to you. If somewhere it said feet, you want to make sure you put feet or inches. All right, on the back of this page, we have basically all converse theorems in the top box. So it just says the reverse of what was on the front. If one diagonal of a parallelogram bisects two angles, so if you know that you have a parallelogram and one diagonal is bisecting the two angles, then it must be a rhombus. You can use the parallelogram symbol if you want, so you don't have to write the word out. So then we would know it is a rhombus. All four sides are congruent. So just the converse of the front. Another converse, if the diagonals of a parallelogram are perpendicular. So if I show you that the diagonals are intersecting to form right angles and you know it's a parallelogram, then you know that it is a rhombus. Last one says if the diagonals of a parallelogram are congruent. So if you know that BD is congruent to AC, or AC is congruent to BD, then it must be a rectangle. So we have a couple of problems below. And this one probably should have markings on it to indicate that it is indeed a rectangle. Okay. If you know that both pairs of opposite sides are congruent, then it's a parallelogram for sure. And then, since one right angle box is given to you, and you know that consecutive angles have to be supplementary in a parallelogram, this would have to be 90, this would have to be 90, this would have to be 90. Okay, so we do have a rectangle. And we know that a rectangle from today has diagonals that are bisected and congruent. So the diagonals are bisected, or bisect each other, let's say. And the diagonals are congruent. So that means we're going to put one marking on all of the little pieces instead of two. So one, well, actually I guess we have to do three, huh? Because I already used the one and the two. So put three markings on all of them, just to differentiate from the two sides. Which I don't like that. There is a question like this on your test. A lot of students miss it every year because they don't remember to mark all four pieces are congruent. Once you do that, you're going to use prior knowledge about isosceles triangles. Okay. So let's start with that top triangle. So we know the vertex angle is 1/16. Then let's define the measure of angle 3. Well, in an isosceles triangle, we know that the two base angles would be congruent. What would each of those base angles have to be in that triangle? So all I did was I redrew this top triangle over here. So we can kind of differentiate. What would each of those have to be? Maddie? 32. Good. We would get 64. And then we have to cut that in half. So this would be 32 and 32. So the measure of angle 3 is 32. And so is the measure of the unnamed angle. All right, how about, what other angles could we identify? Jeremiah? 1 would be what? Why? Good. Remember, the vertical angles theorem says that vertical angles are congruent. So angle 1 is 116. What other angles would we know in this picture? Maddie? Angle 2 would be? Yes. These form a linear pair. They have to be supplementary. So this would be 64. You do not have to write y, but I always do on the notes and on my homework answer piece so you guys can figure out where I figured out that number. And then lastly, what would 4 have to be? Come on. 58. You're going to use this isosceles triangle, okay, that has 64 as the vertex angle. So we would do 180 minus 64 and then divide that in half. And we would get 58. And that was using the isosceles triangle theorem. Yes?
Since it's a rectangle, it makes that a right angle, so I just added 190.
Oh, so you use like alternate interiors to move the 32 down here? Or did you use it up here?
I used
This
that.
one. This one? So he knew that these two have to add up to 90, so he just did 90 minus 32. That works too. Remember, this is a parallelogram, so you can also use alternate interior angles if you would need to, because it has parallel sides. All right, number 4 is a rhombus. Okay, look at our sides. What did the theorem tell us about the rhombus and the way that their diagonals intersect? This is the one I started and said if you don't remember this one, you may have trouble solving. Luke?
Bisectors are perpendicular.
Good. They are perpendicular, the diagonals. So you should be adding in 4 right angles. So that immediately tells me that the measure of angle 2 is 90 degrees. Done. Okay. We also know that the diagonals act as angle bisectors. So that means that this angle is congruent to this angle and these top two. So those would all be the same measure, and they tell us one of them is 50, which means that 1 is also 50. These would also be 50 if you want to fill it in. How can I figure out what 3 and 4 would be then? Right.
Triangle sum.
Triangle sum with probably this triangle. Okay, so it would have to be 180 minus 90 was 90. 90 minus 50 would get me 40. So 3 would be 40. And then if you want, you could just remember that this diagonal bisects the angles, so these are all going to be 40. Or you could even use alternate interior angles because a rhombus is a parallelogram, so it's still parallel. So both of those would be 40. But if you wanted to, you could label all of them as being 40. All right. The next few ask us to determine whether the quadrilateral can be a parallelogram based on its description. If not, write impossible. If so, see if it can be classified further as a rhombus, a rectangle, or a square. You must explain how and why you reached each answer. Again, you may want to sketch a picture, you don't have to, but it may help you to interpret the problem. So I want you guys to read through both of these and see if it's possible for a quadrilateral to have congruent diagonals and have one angle of 60, one whole angle of its 4 angles be 60. So see if that's possible, and then also read through this one. Basically, you're dissecting what shape has congruent diagonals, list out what those might be, and can it have an angle of 60? Same thing with this one. Which shapes have perpendicular diagonals? Which shapes have 4 right angles? Can that coincide to give us the same shape, and is it a parallelogram? So think through those. All right. What shapes, for number 5, have congruent diagonals. What shapes have congruent diagonals? Look back at your theorems if you're not sure from today. There's only one listed in our notes today. Congruent diagonals. Luke? A rectangle. If we go back to our theorems, the diagonals of a rectangle are congruent. The rhombus does not have congruent diagonals. So if you look at it, this one is longer than this one. Okay? So, based on this statement, rectangle. Now, technically, a square is a rectangle, so a square would also have these properties. Can a rectangle or a square have a 60-degree angle? No. Has to be 90. It is talking about one of the four angles, not like that if they're cut in half or anything. So this is impossible. Only rectangles and squares have congruent diagonals. And each angle would be 90. All right, the next one. A quadrilateral has perpendicular diagonals. What shape has perpendicular diagonals? Diagonals that intersect to create perpendicular segments. Marquise? A rhombus. Now remember our little graphic organizer, we had rhombus and rectangle like at the same level, but then the square was below it. So a square also is a rhombus. So we would say a rhombus or a square. It tells us that it has four right angles. So yes, this is possible. It would be a square. Diagonals mean that it's a rhombus, four right angles means that it is a rectangle, and both together mean that it's a square. Or you can just think of how we did it like this. Again, when we get you the graphic organizer tomorrow, this might make a little bit more sense because I have like that little parallelogram, rectangle, rhombus square thing so you can see the visual representation. But you do want to remember that a square is a rhombus, so it takes on all of those properties. All right, the last three theorems are really short and simple. We have an isosceles trapezoid, two theorems about that, and then the kite. And then just applying some properties, and then this will be it. So this one's kind of easy. This should say a trapezoid. The base angles of an isosceles trapezoid. Maybe it does say that on your note sheet, but it doesn't say it on my board. It's a triangle. Change triangle to trapezoid. So just like the base angles of an isosceles triangle are congruent, the base angles of an isosceles trapezoid will also be congruent. So if you know it's an isosceles trapezoid, meaning you have one pair of parallel sides and one pair of congruent sides, then you would know that the two bottom angles are congruent and the two top angles would be congruent. Again, this only works in an isosceles trapezoid. The next one talks about the diagonals of an isosceles trapezoid, and it tells us that those are going to be congruent. So if you have an isosceles trapezoid, you would know that AC is congruent to BD. We wouldn't actually put markings because those are not bisected. They don't get cut into equal parts, but the whole length of one would be congruent to the length of the other. The last one talks about a kite. Remember, a kite has adjacent congruent sides and no parallel sides. So if you have a kite, then the diagonals of the kite are perpendicular. And if you think about like the back of a kite, this isn't a great kite, but if you think about the back of a kite where there's like two wooden sticks that are going, they would have to be intersecting to form right angles. This could be proven using like right triangles and triangle congruence. See if you guys can try 5 and 6 real quick while I'm passing out your homework. So make sure you read, don't just look at the shape. This says it is an isosceles trapezoid, so you want to add in markings that AB is congruent to CD. It's the non-parallel sides. So what would the measure of angle A have to be? Remember, these are our parallel sides. What would the measure of angle A have to be? Marquise? 78. Remember, these are going to be supplementary. And then the theorem tells us that the base angles are congruent. So this one would be congruent to this one. So D is also 78. And the top two are congruent to each other. Makes C 102. Be careful if they were to flip the picture sideways that you still identify the angles correctly. Number 8, our kite. When you see that it's a kite and you see your diagonals, the first thing you want to do is insert perpendicular in the middle. So the measure of angle 1 would be 90. What would the measure of angle 2 have to be? Maddie? 58, triangle sum. And then actually, these two triangles at the top will be congruent. This would be hypotenuse leg theorem, if you were to actually prove it. And then using CP, CTC, these would be congruent to each other. So it would be 32. Do your best to complete that homework, and then tomorrow we will start reviewing for our test.